Mod 12 study guide. Let's do this. Triangle ABC, awesome. They tell us that BC is parallel to EF. Good. Therefore, I can use what we learned in 12.1, triangle proportionality theorem, which basically says, well, if these two lines are given to us as parallel, then the sides, the line segments, should be proportional to one another. Okay? So let's finish our proportionality statements based upon the triangle proportionality theorem. So, AE, they tell us AE, that longer guy on the left-hand side, is proportional to EB. Okay, well, who follows the same pattern on the other side of the triangle? What about AF, that rich guy, with FC? So the rich guy on the right-hand side will go first on our little statement. So AF, basically the longer line segment on the other side, divided by the smaller guy, or smaller segment, CF or FC. I like staying alphabetical for some odd reason. Okay, so that's how I saw that one. Part B says AE. All right, so that rich guy is proportional to AB. Oh, AB is the whole guy. Okay, so if we follow that same pattern, then, well, we have the longest guy there, but then the whole other side, AC. So AF, which is the longer line segment, divided by the entire segment, AC. Okay, if we were following the same sense of proportionality. Notice the markings that I'm doing on the paper to give you that visual sense of things. That's what your mind can do if you just simply train it to think that way. Saves you time. All right, so part C, AC. AC. So AC was the whole long guy, the entire side, is proportional to AF, and then they say divided by the small guy. Okay, or the richer guy. But so if we follow the same pattern on the other side, it'd be AB. Oops, sorry, I wrote it in the wrong spot. AB divided by, let's see, our small guy is AE. So AE, there you go. All right, so part D. Part D, we'll pick purple. It's kind of like purple, but it's more, I don't know, purple. All right, FC, 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 FC. Small guy divided by the whole thing. Okay, so small guy on the other side would be BE divided by the whole guy, AB. So when you're doing proportionality statements, it's really just a pattern in respects to the other side of your triangle. Okay? Try to do the markings a little bit better than I did. Obviously, it's in my head, so I'm not really, too clean, but, you can try. Try to keep it cleaner on. Just notice the patterns of my process. Okay, number 2. Triangle GHJ is shown below. Awesome. And they ask us if FI is parallel to HJ, and then it says it again for some odd reason. It's okay. So basically, we're just using the triangle proportionality theorem again. Awesome. So these guys, they're asking us if they are parallel. Well, if they're parallel, then this guy, FH, needs to be similar to IJ, and the same thing needs to be said to FG to GI. So let's find out. So I'm going to set up my proportionality statement. I already said that FH needs to be proportional to ij. And then FG needs to be proportional to GI. So they gave us numbers, values, distance, in centimeters, and let's see if their proportionality holds true. So FH was 3 centimeters. I'll just leave it as 3. IJ was 2.4. And then FG is 5. And GI is 4. So if you were to do this in your calculator, and I'll just grab mine right now, I'll double check to see if these two values are the same. So 3 divided by 2.4. Okay, so I get 1.25. Okay. If I did the same thing with 5 divided by 4, something interesting happens. I get the same number, 1.25. Apparently my little touchscreen won't let me go over there. But I get the same thing. 1.25 equals 1.25. So if you get the same two numbers equaling one another, then we can say that both Fi and Hj are parallel to one another because they're proportional to one another. Okay? If your two numbers were not the same, okay, then your two lines will not be proportional, and that would be by, okay, so you can say this. You could say Fi is parallel to Hj, and you can say, well, first we went ahead and used the values. They're proportional to one another, and you could say since the triangle proportionality theorem. Okay. Check with your teacher to see if they want to make sure you write it all out. If not, that would probably suffice. So, and definitely have a value, just so you can show me that, you know what, Mr. Webb, I used the lengths they gave us and they're proportional. Okay? I'd be happy. All right, number 3. A person in a building casts a shadow at the same time of day. Awesome. What type of geometric measure can you use to calculate the height of the building? And that will be indirect measurement. I think the only person who would probably not want to use indirect measurement will probably be Batman. I think he'll use his grappling hook, and he'll probably just, fire all the way up there and be like, it's 45 feet. And you're just like, all right, thanks, Batman. But, you're just this guy right here. You're not going to climb all the way up here and, probably slip and fall and just, you don't want to do that. It's black. Okay. So it's probably just safer to use indirect measurement. It'll still work and give you the answer. All right. Write a ratio to describe the relationships between the person, the building, and their respective shadows. Okay. So if we do that, let's see. All right. So your height. Oh, well, let's see. We want to find. Okay, let's say we really care about finding the building's height, like in part C. So if you really want to find the building's height, okay, basically what you're going to do is you want to find KL. Now, KL should be proportional to your height, QR. And then the building's shadow, LM, should be proportional to your shadow, RS. And that's a ratio that you can use to actually solve, just like in part C. So they're already kind of setting you up. All right, so a person is 5 feet tall. That'll be QR, okay? And their shadow, which will be RS, is at 3 feet. And the building shadow, which is LM, is 27. How tall is the building? So KL is the height of the building, and I'll just use H to represent height. We can cross multiply, or like a champ, we can just multiply both the left-hand side and right-hand side by 5. And you will get 5 times 27, which is 135. And then after you get 135, you will divide it by that 3 in the denominator. And eventually you'll find out that the height of the building will be 45 feet. Okay. And for the justification, okay, make sure you understand this. Okay. So you can say, well, because using indirect measurement and that we have similarity of right triangles. Okay, so this is a right triangle, this is a right triangle, and there's similarity with right triangles. You're able to set up your ratio or your similarity statement, and then you just substitute in your values, and I was able to get my height of my building, and that's because of similarity in right triangles. And that's all you have to say. I should be happy. All right, 5 through 6. What is true about JK and MN? Justify your reasoning with the correct theorem or postulate. Okay, so just looking at this, I am either going to be looking at the triangle proportionality theorem or the converse of the triangle proportionality theorem. Okay, so let's take a look. Number 5, what is true about KL and MN? Justify your reasoning with the correct theorem or postulate. So again, like I said, probably going to use either the converse of the triangle proportionality theorem or the proportionality theorem of triangles in the first place. All right, so here we go. Basically, we have some values. Sorry, my daughter was like banging pans in the back. Let's see, what is true about K and L and M and N? K and L. Alright, so we're talking about this guy and this guy. Justify your reasoning with the correct measures. Okay, so let's see if they're parallel. Okay, let's see if they're parallel. If they're parallel, this guy should be proportional to this guy. This guy should be proportional to that guy. Alright, so let's find out if that's the case. So we could say KM should be proportional to Ln, okay, the small guys, should be proportional to KO to LO. Okay, it sounds like a really good hip-hop artist. Oh, have you heard KO over LO? Alright, so let's see, KM is 85 feet. Sorry, if you're not laughing with life, I feel like we're not doing it right. So let's see, Ln is 225. Awesome. And that should be proportional to KO, which is 85 feet, over LO, which is 225. Oh, ha! You know, if you just look at the two, they're both the same. You know, they're terrible, ugly fractions. Actually, not really that ugly. They both need the divisibility of 5, but they're the same. So since they're the same, you can say that KL and MN are parallel, and you basically just say, well, because of the triangle proportionality theorem. Okay, and that's basically the answer there. This guy is parallel to this guy, since, okay, triangle proportionality theorem, and then also just, you know, show your work, show your statement. I would be totally happy right there. Okay, what is MN? Okay, so basically we have to know that these guys are parallel, which we do, and that they must probably have to be proportional. Okay? So, if you think about it, the distance from here to here and here to here, if you remember about dilation, okay, the distance from KO is 85 feet, but M is twice as far, okay? So if that's twice as far, and if you could double check here on the other side, that's also twice as far, all right, for N. So if MN is twice as far away, well, if KL was 115, then what's twice of 115? So you could say MN, all right, oh, she's banging pots again. MN is 2 times KL. So 2 times 115 will equal 230. I think. Yeah, sounds right. And 230 what? Well, we're dealing with feet here. So 230 feet. Okay. So you just have to realize that whole concept of dilation again, how scale factors kind of come back to haunt us. They're always in the background with the sciences and maths. They're just always in practice. She's really banging those pots and pans. I feel like the pop quiz question should be like, what was the annoying thing that was disturbing Mr. Webb on his study guide? Pots and pans. That would be the answer. Yeah. Sorry, I love kids. That's awesome. All right. 7 through 9. Determine the geometric mean for each pair. It's awesome. Finally. All right. So geometric mean. This is all you have to do. Basically, a geometric mean. Okay. Square root. And then it's the product of those two numbers being square rooted. So also simplest radical form. Okay. So basically, you have the square root of 60 here because 5 times 12. Remember your square, was it square root or factoring tree? Oh, factoring tree, oh, factoring tree. I'll find the primes of u. So here I am just dealing with the multiples. And then we circle our factors, our multiples. And then this 2 decides to rat out on this 2. This 2 finds out he got ratted out on. And he does a magic trick to disappear the prison. This 2 gets out of prison. This 3 and this 5, they don't have anybody to rat out on, so they stay in prison together. And, well, they'll multiply and just stay as 15. Okay, so your geometric mean for these two guys will be 2, because the 2 ratted out on the other 2. And the 3 and 5 couldn't escape, so they're stuck together as a 15. Okay, don't go to prison. Okay, be good. And that'll be the answer for that guy. Another reason it's not plus or minus, mind you, is because there's no such thing as negative distance with geometry. Okay, do the same thing for number 8. And basically just 6 times 24. And you get 144. Square root of 144. Awesome. That's just, well, 12. So x equals 12. Nice. Okay. What's the geometric of 5 and 20? Well, you could actually do this in your calculator real quick. You could do 5 times 20. You get 100. What's the square root of 100? You should already have 10. And notice how my brain is much faster than my hand, and it would actually be much faster in your calculator. You just have to be able to see it in your head, like a crazy person. So there's your geometric mean for that one. All right, so triangle DGE, proportion that can be used to find DG. And let's see, right, proportion that can be, oh, okay, so it's this. It's this. All right, this stuff. Similarity in right triangles. So this is the geometric means theorem. Remember, there's actually technically 3 triangles all together inside. It's like those little dolls in Russia. Okay, they just fit all inside each other, so they're all similar. Okay, so right of proportion can be used to find DG. So if we cared about DG, DG is the hypotenuse of the smaller triangle. Okay, so DG, okay, we're thinking about DG. Looking for a proportionality statement. Who's another hypotenuse that we can use? I also know that GE, okay, is a hypotenuse for the much larger triangle, so I could probably use him as well. So hypotenuse with the other hypotenuse at top. And the base for the smaller guy was GF, or FG, probably FG. Yeah, FG sounds much better. Yeah, FG. I like that. I don't know, I like staying alphabetical. And the base for the other larger triangle will be DE. Okay, that is one of many proportionality statements that you can use to find DG. I just prefer this one because I get to leave DG up in the top left, and there's no reciprocal rules or anything that just gets a little bit more worky. All right, here we go. In triangle DGE, all right, so we're still dealing with this image, and they give us values. So let me clean this up. So triangle DGE, GF is 2, awesome. GE, the whole thing, is 10. Therefore, FE's probably got to be 8, right? Because 10 minus 2, right? 8. So I could just use quick logic right there. What is DG? Well, first we have to find, we already have the base for, DG, well, the small triangle, right? So yeah, we're still trying to find DG, but we can use DF. We already know that DF, okay, DF equals the square root of 2 times 8. This is the geometric means theorem, okay? So if you remember in your notes, it's basically this guy times this guy, all square rooted should equal that guy, okay? So you'll get DF, which is square root of 16, which is 4. And since you found DF, we have 2 parts, or we have the base and the leg of a triangle. So we'll use Pythagorean theorem, Pythagorean theorem, to find DG. So DG equals one side squared plus the other side squared. And you're going to get 4 plus 16. Don't forget DG has to be squared as well. Can't forget. Okay, so you're going to get square root of 20 eventually to get DG, because you have to square root to get rid of the square. And you can go ahead and get it into radical form, and you can do your factoring tree. I'll do it over here. 2 times 10, 2 times 5. This 2 can rat out on the other 2. The other 2 finds out you got ratted on, disappears. So DG equals 2 times the square root of 5. And that's one way you could find DG. Okay. So notice how I had to use geometric means theorem and Pythagorean. So, right triangles. Awesome. All right, so what are the similar statements for the triangle below? So we have 3 different triangles. Let's start with The small one, oh wow, there's a lot of statements here. Okay, so we have PR's hypotenuse, the smaller triangle, is what I'm talking about. Okay, so PR has to be proportional to the hypotenuse of the bigger guy, QR, let's use their bases, all right, because it's all about that base. So PR, his small triangle, his base was RS, and the bigger triangle, his base was PQ. That's one of them. So again, there could be multiple similarity statements. That's just one. All right. So let's see. Let's get a couple more. Okay. I want you to just get a good amount of these. So if we get the smaller guy, actually, you know what? Let's forget the smaller guy. Let's just get the medium-sized guy with the bigger guy. So the medium-sized triangle will be, oh, whoa, look at that. I already did the medium, right? PQ, it's not the hypotenuse. Oh, yeah, it's the hypotenuse of the medium one. And R, oh, okay. So, addendum, let me do this all over again since I messed up like a total noob. Yeah, you have to pay real close attention. So, PR is proportional to the hypotenuse of the medium guy. The medium guy is this one, okay? So his hypotenuse is PQ, but the bases, okay? It's all about that base. So the small guy's base is RS, but the small side length for the medium-sized guy is QS, okay? Now let's, that's one of them, okay? Another version would be, let's see, you can use the bigger guy with the smaller guy or the medium guy with the smaller guy. It's up to you, but that's just one of them. Okay, that part with the part, corresponding parts of congruent triangles, okay? So that's just one of the ways to see it. I'm going to move on because I feel like I want you to experience that more on your end, so probably like a practice assignment I'll give you, okay, just because it's pretty tricky and I want to make sure you experience it some more before your test. All right, triangle GTH is shown below. Awesome. What is X? So this might get a little messy. So X, this guy. All right, first things first, we need to find out what Y is. The picture is a little skewed, but they do say that this is a right angle, so therefore this has to be a right angle, okay? Because a straight line is 180 degrees. So we have the hypotenuse already, which is 65. And this is actually for Y, so 65 squared, the hypotenuse, equals one side, which is GS, which is 25, and we'll square that, plus, we'll call this one just Y, and we'll leave it as squared, okay? So go ahead, get a calculator. 65 squared is 4,225, and the square root of 25 is 625. And the y squared just stays there for now. Subtraction property, get rid of the 625. Do it on one side, do the other. And then you're going to get y squared equals, let's see, 4,225 minus 625, 3,600. Oh, wow, that's nice. And then you're going to square root both sides. And then you're just going to get y equals 60. Nice. So now that you found that guy, okay, we're going to go ahead and find the rest of them now. It's kind of like a puzzle. You have to solve one part before you get to the next one. So let's see if we can find out x. We can. So for x, we know that, well, y is 60, but it has to equal 25, or the square root of 25 times whatever x is, okay? And that's because of the geometric means theorem. So I'm going to go ahead and start substituting. We got 60, because y is 60, equals the square root of 25 times x, which is really just 25x, right? 25 times x is 25x. All right, we're going to go ahead and square both sides. And the reason we do that is to get rid of that square root. We'll get 3600 on the left. And then we'll just get that 25x and we're outside. Okay. Use the division property. And you finally get x. So basically 3600 divided by 25. Nice. Well, not that. That's ugly. That's horrendous. I got 144. Okay. So x is 144. Awesome. What's also nice about this is, yeah, I have to use the geometric theme. Notice how I started with Pythagorean, and then I eventually had to use the geometric mean theorem. All right. So to find z, it's not as bad. We just go to the Pythagorean again. So we already have 60, which is the leg of the medium-sized triangle, and x, which is the base of the medium-sized triangle. So we have z squared equals the leg squared, which is 60, plus 144 squared, which is the base. So z squared equals 3600. And this is an atrocious number. And I got this from squaring 144. And then I'll add that with 360. And I get z squared equals 24,336. On your test, you can leave this in your calculator and just roll off of it, okay? But that's up to you. Once you square root it, because you have to get rid of that square on the z, you should be able to get z equals 156. Nice. And that's how you handle this kind of problem. Use Pythagorean and geometric means theorem. All right, and that will be it. Good luck.